All right, so let's begin. All right, so first off, cell phones evaluations, you should know by now this is the last session. So, okay, so thank you all for coming to this session. Cutscenes everywhere, the tech behind StarCraft II storytelling. We're going to be talking about the process that we went through while building the cutscene editor for Heart of the Swarm. All right, so before I begin, I'm going to give you just a bit of background on myself. So my name is Matt Shimberry. I'm a senior software engineer at Blizzard, where I've been working on StarCraft II for the last 6 years or so. While there, I've primarily been focused on the editor and art tools. And I've always loved working on tools because, to me, the better the tools are in a game, the closer the game can get to the artist's and designer's vision. And that's really important to me. All right, so we're going to go through 4 major topics as it relates to the cutscene system. First, we're going to talk about why we needed a new tool in the first place. We're then going to go over some of the design process we went through in the early days of the cutscene editor. I'm going to then talk about the tech design. And finally, I'm going to go over some of the lessons learned. All right, so traditionally, there are 2 main ways to author cutscenes. The first is to actually script it out like game events. So what I mean by that is you're using triggers or Lua script or node graph or whatever it is to actually use game actions and game actors to play out the cutscene. So you'll do things like cut to camera A, play line B, wait 5 seconds, et cetera. You're actually using game actions, right? And the other way is to actually animate it out like a movie. And so using 3ds Max or Maya or whatever it is, you're actually doing a full-on animation and treating it more like a film. All right, so both of these have their pros and cons. First, for the scripted scenes, one of the cool things about them is that changes are really easy to make, right? So if your writer decides he wants to swap dialogue lines or whatever, you just go into the code and you can just change the order of the code, and it's not a problem at all. But one of the problems is that it requires a scripter, right? It requires someone who's familiar with your scripting code and your game engine. And this may not be the person who's best suited to creating a cinematic experience. Or maybe you have like an artist, sit down with them or whatever. But it requires a lot of extra knowledge. The other problem, too, is it's inherently a non-visual process, right? When you're using a paradigm where you're actually like typing out code over here, and then you go back to, you see the result on the other side, there's a disconnect there, right? And that disconnect can slow down iteration time, and it can, you can lose some of the dynamic feeling of your cutscenes because you're creating something than what you're actually getting the result of, right? So on the animated scene side, one of the good things about this is it is directly visual, right? So if you want your character to walk across the camera, you're actually going into the worldview and manipulating them in the worldview to go across the camera. So you're directly interacting with what you're building. But the bad side here is that it requires an animator, right? So if you wanted to have a designer or an artist go in and actually change the pacing of one of your scenes, you'll have to kind of ramp them up in Maya or Max or whatever, and that can be hard. The other problem is these can be really expensive to make, right? Now, I'm not going to lie. The fully animated scenes, they tend to be some of the highest quality cutscenes that you'll get, but they're really expensive to make. You're actually animating out like every single bone for every single scene. And because they're expensive to make, they're also expensive to change. And so what happens is often you have to lock down the story before animation begins. And that can be really stifling to an iterative environment. If you want to be able to make changes after seeing the animation, it can be really hard. OK. So for StarCraft II, we have 4 main ways that we tell the story. First is the fully pre-rendered scenes. So these are the actual like movie cinematics that start at kind of at the start of the game and the end of the game. And these are made by our very talented cinematics team. And they're created just like film projects. But I'm not going to be talking about these at all. That's kind of made by a different team with a different system. Then you have the mission moments, right? So this is when you're actually playing StarCraft II. And maybe you just destroyed a base or something like that, and a portrait of Kerrigan pops up and tells you what to do next. These were created primarily as game actions. Then you have the IGC cutscenes. In StarCraft, these are the 10 or so cutscenes that kind of advance the main plot of the story. And these are built in the real-time engine with our real-time tools and playback. And they're still treated very much like a film. Finally, we have the conversations and mission briefings. So this is when you're in the story mode set of StarCraft II, and you click on a character, and maybe a short little 30-second kind of conversation or a mission briefing will occur, kind of telling you what you need to know or telling you kind of a bit of a side plot or something like that. And this is what we're going to be focusing on. These conversations and mission briefings were very difficult to work with in Wings of Liberty, so this is what we really wanted to improve upon. So in Wings of Liberty, we had these mission briefings, and typically what would happen is right before a mission would begin, you would have two characters kind of talking, and we wanted these to feel a little bit more dynamic, right? So we have a procedural conversation system in StarCraft II where two characters will just kind of trade lines back and forth. But these mission briefings, we wanted them to feel a little bit more cinematic, right? So in Wings of Liberty, what we did was we used the trigger editor to build these using the game event system. But we had a lot of trouble with that, in particular because there's no visual feedback in the trigger editor. The trigger editor was built for editing game logic, not for actually building cutscenes. And so it was really hard to create the cinematic experience. In particular because you had to reload the game for every single change that you made. So you'd go into the trigger editor and you'd say things like, Rainer walk to point A, wait 5 seconds, deliver line B, stuff like that. And then you you save that change, you reload the game, and then you have to progress back to that point and watch the cutscene in its entirety to see what actually happened. Kind of most importantly, though, the trigger editor has no camera support. So in order to actually add cameras to your cutscene, which are very important, obviously, you had to go to the terrain editor and place a camera in the terrain world there. But the problem is that while you're placing it in the terrain world, you have no idea what the current state of your cutscene is. So you have to kind of just blindly place the camera by looking at things like, oh, where's the piping on there, and try to line that up to the left edge of the camera and things like that. And then, of course, you have to save the map and reload the game and progress back to the point and watch the whole thing again. And so the iteration time was really slow. So this is a shot of what one of our cutscenes looked like in Wings of Liberty. So you can see here that you can't get any kind of information at a glance. You don't know who the characters are. You don't know where this cutscene takes place. You don't know the duration of the cutscene. All of the kind of important things you want to be able to see at a glance. And that's because this wasn't built for that. This isn't the right tool for the job. And so this is why we knew we had to build something new and specialized for the cutscenes system. So that's what we figured out. All right, so now let's walk through some of the design that we went through. So in the very beginning, we knew that we had to figure out what our problem was, right? And so what we knew our problem was not is that our goal wasn't to build a better tool, right? Our goal was something else. But building a better tool is a way to get there. But we knew we wanted to separate out that. That's just a means to get to the goal. So we took a step back, and we had lots of meetings and discussed, and came up with two kind of tangible goals that we can build off of. The first is we wanted to have better storytelling, and we wanted to have more story moments. OK, so now with these goals in mind, we can say, OK, well, what is it? How can we get there? And we actually looked at a couple different options. But looking at these two goals, we did decide, OK, you know what? We do want to build a new tool. We want to have a new process to support these two goals in Heart of the Swarm. So you'll hear often at places like GDC or wherever that you should always be user-focused, right? User-focused in your gameplay, user-focused in design and usability and things like that. So we took the same approach when building the cutscene system. So one of the most important things, actually the most important thing that we did was to involve the content creators early, right away. Very often we get into situations where a producer will say, hey, make this thing. And so the tools programmer makes the thing, and then he passes that thing over the fence, and that's it, right? That's all the interaction you have. But we wanted to actually involve the content creators right from the beginning. And this was really important because what it did was it created a sense of engagement with the artists and animators that they felt like they were building the tool too, because we were all collaborating, we were all building the tool at the same time. And this helped get past that common problem we have with tools where artists will silently suffer, right? Instead of silently suffering, they would be at my desk all the time telling me all the things that were wrong, which is great. That's what I want to know. I don't want them to just kind of go off for 3 weeks and not tell me when something's wrong. And so when I'm saying that we involved them early, it really just meant that we talked, right? And I mean, it sounds simple, right? But that's all it was. We just talked, right? We would figure out, OK, what do we want to get out of this? What kind of cutscenes are we hoping to make? What's the weirdest cutscene we might make? Things like this. So we just kind of sat around and talked and would take notes and figure out what is this that we're building? And building that relationship with each other, too. And it's really important, too, that during this phase, everything was entirely pie in the sky, right? I didn't care what kind of tech we were hoping to leverage. I didn't care what the production realities were at this point, right? We're just building wish list items, right? We want to stay in this kind of magical land of fantasy where everything is possible, because that's how we can get kind of the best ideas out during brainstorming. And finally, it's also really important to ask open-ended questions in this phase. Everyone's going to be rooted in the old way of doing things. And so every single change that they're suggesting or thinking about is from that point of view of the old way of doing it. So they're going to say, OK, well, I want to do kind of this old way better, but that's not what we're actually trying to get out of this. We want to actually have a totally new pipeline, a new system. And so you have to ask open-ended questions and kind of challenge them at times and say things like, well, why do you want this? What are you hoping to get out of this? Because you got to break past that idea that they're still kind of going through going through this in the old way. All right, so after we had plenty of discussions, we started to move on to mockups, right? And 100% mockups are required, right? Mockups really help you have a solid thing that everyone can work on, because just as humans, we're going to have a different model in our head as we're talking about things. So I think I'm talking about one thing, you think you're talking about something else, and we're going to have a disconnect there. And so having mockups has a common thing that we can all point to and say, OK, that's what we're trying to do. So we started with the whiteboard drawings. And of course, this is a very common thing. Whiteboard drawings are great. Because they're very easy. You just go up there and you kind of sketch things out. You can even go up and we would pantomime kind of what the workflow was, how you'd be working on cutscenes, stuff like that. And it's really easy to see and make changes. And again, this entire time was user-focused, right? We would have the artists and the animators in our room drawing it out with us. We then moved on to the Photoshop mockups. Photoshop mockups are great because they show real scale. They show, can your UI actually fit on the screen? What does it actually feel like? And most importantly, people start to get it when they see Photoshop mockups, more so than, say, whiteboard drawings or wireframes. We actually skipped the wireframe phase for cutscenes. Photoshop mockups feel real. And you can give them to someone and say, OK, what do you think of this? And they can actually get past that boundary of having to use their imagination. And so here's a mock-up of the final mock-up of the cutscene editor. We've got some annotations on there for talking points as we're showing, but this was a real turning point for us as we built this, because everything here is totally fake. It's just a mock-up, but we could hand it to people, and people would be like, "Oh, now I understand. Now I see what you're trying to make." And that it really helped give us confidence that we were moving in the right direction. And we even had times where people were like, "All right, cool. When can we start using this?" Of course, at this point, it's nothing but a PSD, but it really gave us the confidence that we needed to keep moving forward. And to show you how important this mockup was during the development process, here's a screenshot of the final cutscene editor as we launched in the 1.5 patch. And so it's basically the same thing, right? If I kind of flip back and forth, you can see that all the main controls are there. The only main difference is we added the property sheet to the main frame, and that was because through usability testing, we realized that kind of deserved to be up there. But otherwise, it's basically the same thing. So while I've got this up here, I'm going to take a quick aside and say, and kind of walk you through just some parts of the cutscene editor here. Just to kind of give you context, I mean, the main point of this talk is not to show off this thing or kind of give you a tutorial on it. I just want to give you a little bit of context of what we've got here. So right in the center there, you've got the viewport, of course. And that's where you can do manipulation right in the viewport and move things around, kind of anything you'd expect from any standard animation software. We've got the a library on the left for managing your assets, and you can kind of keep track just below that of all the nodes that are currently in your scene. The bottom there is the main meat of the timeline. And so that the timeline there, it behaves just like you'd expect from any major animation software, where you can click on a timeline and scrub around, move things in real time on the timeline, and see how everything updates as you're making a change. That was kind of the key thing we were going for. And we've got a couple other features that you'd expect. Things like we've got a curve editor. We've got a camera editor, conversation integration, so we can keep track of the conversations and how they work in the cutscenes. A director window that kind of gives you a preview of exactly what this looks like when it's rendered back in the game. Things like that. So totally a fast whirlwind, but I just wanted you to have at least a little bit of an idea of kind of what this thing is. All right, so after the mock-ups, we then moved on to the design docs. And so the design doc was just a Word document where you go and describe everything. I mean, nothing crazy there. But it was very casual, right? We did it from a user's point of view. This wasn't a tech design doc. It was just, what is this thing? And writing it out. And so we went through and described every single button and every single feature of the editor from the user's point of view. When you click on something, what happens? What does it do? Things like that. And when it was done, it was about 19 pages or so. And we took that document, we passed it around to all of the stakeholders, right? The producers and the artists and animators and anyone else involved in the cutscene editor process. And of course, nobody read it. But that's OK. I didn't realize this at first. It took me a little bit of time to realize that it was OK. But what I realized was it's not about getting buy-off from the stakeholders, right? Because we've been working with them the whole time, because we already, the animators and artists, they already know what this thing was because they helped design it. We didn't need buy-off from them. The main purpose of the design doc was really just to be a brain dump, so that 3, 4, or 5 months later, when we were implementing things, we could remember how, what answers we had to some of the hard problems, things like that. All right, so once we kind of had a really solid idea of what this thing was going to be, we took a step back and decided to come up with some core principles. And these core principles, they're kind of like core values at a company, right? We wanted to have something that we can pin up on the wall, and it would be kind of our compass to make sure we always had a vision moving forward. In any difficult decision we had to make, we wanted to keep these core principles in mind and never violate them. And this was really helpful to keep us kind of on track. And you're going to see them, and they're going to seem really obvious in hindsight, right? But they weren't necessarily obvious, and they were really helpful to keep us grounded and to keep us moving in the correct direction and not make any decisions that might kind of bite us in the ass later. So the first one here is what you see in the editor must be exactly what you see in the game, right? And so it sounds kind of obvious. When you're building something, it should kind of look the same. But at least in the StarCraft editor, we present things differently in the editor and the game all the time. But it was really important to us that we cut out that step where the artists had to load up the game to see what their cutscene looked like. We wanted them to be able to have full confidence that what they're building in the editor is exactly what they were going to get in the game, so they didn't have to load it up. And the only way to have that confidence is if everything was always exactly the same. The second one is, when you're at a given time, the scene must always look the same. Again, sounds kind of obvious. When you're building a cutscene out, you don't want it to kind of look random every time you're building it out. But a lot of game engines, and StarCraft in particular, are kind of fundamentally built on this idea of variation, right? Variation in animations, variations in sound, randomized particles, things like that. But we thought it would be really disorienting if every time you played back your cutscene, if it looked slightly different. So we had to turn all that stuff off. And on top of it, it also had a lot of implications for things like when you scrub on the timeline. Scrubbing on the timeline must be exactly the same as playing back. Also, as you're editing, you must see that change immediately, right? You can't have a reset process or anything like that. So we always wanted to look exactly the same every time you were at a given time. All right, so now with these core principles in mind, and the design doc, and the mock-ups and everything, we could finally sit down and say, OK, what do we need to build in order to hit this? What do we actually need to build to make the cutscene editor a reality now that we kind of know what this thing is? So we came up with our requirements list. So the first requirement we had was we had to deal with the problem of game versus editor, right? We wanted it to play back identically in the game and the editor, but also editor obviously needs some extra bookkeeping and functionality. The next is that we had to solve kind of the general editing problems, right? How do you change properties? What does undo, redo look like? Save, load, copy, paste, all the kind of the standard editor stuff that you have to deal with. Next, we had to look at scrubbing. Scrubbing was interesting. We had to make sure that we could click anywhere on the timeline and always get the exact same result. And finally, there's a whole lot more stuff that I don't have time to go over, but feel free to ask them at the end or come see me after. Things like multiplayer support, the replay system, localization, the various Kerrigan forms, alternate lines that you could have depending on what planet you went to, the curve system, stuff like that. All right, so that there is our early design process. So we're going to move on to the tech design. So at its core, we knew that we had to have some kind of object that represented the cutscene itself, right? What was the actual cutscene object? Well, we called that the cutscene state. The cutscene state has two main jobs. It is the keeper of time, and it is the owner of all of the nodes, all of the things inside of the cutscene. So that's what the cutscene state was. It's kind of like the wrapper outside of the entirety of the cutscene behavior. So what are these nodes? Well, the nodes are the what of a cutscene. The nodes are, what models are in a cutscene, what animations are in a cutscene, what are they doing, all of the whats of your cutscene. And a node has a GUID, so that way we can refer to other nodes without having to deal with nasty pointers. And nodes also have a parent and a list of children. And so in this way, you end up with a tree structure, of course. And so your cutscene might look like something like you got a root node, and maybe that has a child folder node, that has a child model node, and that has a child animation layer node. And so in this way, you create a structure so that you know how all of the various nodes interact with one another. Then we have the element. So if the nodes are the what of a cutscene, the elements are the when of a cutscene. Kind of the key distinguishing characteristic of a cutscene is that stuff happens over time. And so that's where the elements come in. They are the when of the cutscene. When are keyframes fired? When are sound events fired? When are animations played? Things like that. And so an element always has a parent node because elements always exist inside the context of a node. And they don't have any children because elements are always the leaf items of the cutscene structure. Elements also have a start time and a duration. And so that way we know exactly when the element is in effect. And so then the way we get kind of your generic behavior out of cutscenes is that we subclass out the node or the element, depending on what it is, and build out from there. So you might have an actor node or a model node, animation layer node that kind of derives from the node class. And you've got your animation element, and that has all the behavior of how to actually play back an element, animation on a model. OK. So with that kind of foundation in place, we can look at our first requirement and how we solved it. So we're just going to kind of navigate what we know and what we need here. And so we know that the game and editor playback must be identical, right? But that's easy. I mean, we just put that in a shared project. That's a solved problem we already have. You know, same as graphics or actor or sound or any of those systems that are kind of shared between game and editor. But the game area, that can't know anything about the editor. There are separate projects there. OK, so you keep all the editor stuff separate. You put that kind of on the editor side of the fence. But how do you bridge that gap, right? We're going to have all sorts of situations where we want the playback code to be shared, but at the same time, the editor has all this extra bookkeeping it needs to do to kind of keep track of how to draw the elements on the timeline and present them in the tree structure and stuff like that. And so we did that with the dynamic decorator pattern. So if you recall from the design patterns, dynamic decorator pattern, what that is you can take behavior and encapsulate it into a structure, and then at runtime, you take that structure and you install it into another object, and that object then gains that behavior, right? And so we did that through this concept of the node view. So a node view, I'm going to kind of illustrate out how this works. So running across the center there, we've got the game and editor boundary, right? I'm calling it game on top. Technically, it's a shared area, but game makes it a little bit easier to understand. So on the game side of the fence, we have the cutscene state in the node. That's the playback. That's the actual behavior of the cutscene. So on the node, we added a pointer to a node view. And on the game side of the fence, this actually doesn't do anything, right? It's always null. We never fill it out. Nobody uses it. And it's perfectly fine. It just kind of sits there and doesn't bother anybody. Now on the editor side of the fence, we extend the node view into an editor node view. And the editor node view is where we put all of that behavior for how to draw on the timeline, how to present in a tree, what your display name is, things like that. But how do you get that editor node view into a node? Well, when the editor is running, what we do is every time we want to create a cutscene, instead of creating a cutscene state, we create an editor cutscene state, which derives from cutscene state. And that class there has exactly one job. Its job is to override the create node function. So what the create node function does is first it passes control back up to the cutscene state to create the node. Then when it returns, it instantiates an editor node view and installs that into the node view pointer. Of course, that doesn't care because it is a node view, essentially. But the cool thing about that is that on the editor side of the fence, we can always assume that the editor node view is valid. So when the timeline control wants to draw, it can get the list of nodes. And for each node, it can say, give me your node view, cast it to an editor node view, and then it can pass the draw context into that editor node view, and it can fill out how to actually represent itself in the timeline image. The other cool thing about this is that at some point, we haven't done it yet, but this gives us the flexibility to add a game node view on the game side of the fence so that in the game we can actually draw out a debug timeline if we want or anything like that. All right, so that handles our game versus editor problem. So with that, we're able to keep all of our playback code together, but we can extend out when we're in the editor all of the extra editor bookkeeping. All right, so now it's time to kind of look at the main editing functionality. So objects are really just a collection of properties plus behavior, right? So we took that idea and made properties a first-class citizen. And we did that by using a reflection system. So everything, every node really is nothing more than a collection of properties. And we use the reflection system to actually to handle those properties. And for those of you who are not familiar with the reflection system, a lot of modern languages have them built in. We have a homebrewed version ourselves. But the main purpose of that, what it does is it allows you to register a member of a class into this reflection system to actually register properties of it. You can then query and iterate all of the properties of that class. You can set and get by ID by string. So you don't have to actually care what the member is or what the accessor functions are or anything like that. You can just kind of set and get by ID. And it also allows you to instantiate by ID. So you can create instances of the object based off the string ID. So what that does is it makes it really easy to do things like save and load. So what we do for saving is we start at the root node, And first thing we do is we save off the class ID to the XML. And then for each of the properties in that node, we just save the name and value tuple if it's not default. And so with the reflection system, you can add attributes to a property, such as what the default value is, things like that, and so that we actually can see if a value is default. And then finally, for each of the children, we just call save child recursively. And so that then gives us all of our saving code right there. And the cool thing about this is that we have absolutely zero special serialization code. I mean, this here is how the saving works. It's something like 20 lines of code in the C++. And every time we add a new property or a new class or whatever, we don't have to worry about serialization at all. It just works. And so loading is very similar. For each XML element, we create an instance of that object based off the class ID saved in the XML. And then for each of the XML attributes, we just set the property value based off the string. Very simple. So copy and paste is also similar. And copy and paste is always kind of similar to save and load as it is anyway. What we do for copy and paste is we save out the type ID of the object that we want to copy. And we then save off the array of all the properties and their values to the clipboard. Then when it's time to paste, we create an instance of that object from the type ID we saved off, and then we just run through all of the clipboard properties and set their properties. So now undo, though, that was a little trickier. We decided, for better or worse, to go with a very granular undo system with the cutscene editor, where basically everything, every undoable item is really just a change to a property, right? So every time we wanted to register an undo item, we would just save off that actual property change. And so instead of saving off the entire node or the entire state or whatever, we would just save off the actual properties. We had some trouble with that, which I'll talk about in a second, but this is what undo looks like. Prior to actually making a change, we have to save off the undo item. And so what we do is we see that we're about to make a change to a property. So let's say we've got a property called start, and we're changing the value to 10. And so what we do is we save off that property. So we create a new undo item, and we add the property name and the value immediately prior to the change, and just push that to the undo stack. Then back in the main change code, we just change the property. And of course, with the reflection system, you don't have to use the get and set if you don't want to. You can still use the members like normal. So this just looks like mstart equals 10. Then when it's actually time to perform the undo, what we do is we take that undo item that was pushed onto the undo stack, and we pop it off the undo stack. And now, because we got to handle redo, we take that item and we create an inverse prior to actually performing the undo. So all we do here for creating the inverse is, again, you make an undo item prior to making the change. And we push that to the redo stack. Then you actually can perform the undo. And in this case, we actually are going to use the string ID. And we perform the undo, setting the value back to whatever was saved in the undo item. Nice thing about this, then, is undo and redo, of course, exact same code. We just change which stacks we're looking at. So I mentioned we had some trouble with undo. And that's because you may have recognized, as I was explaining that, kind of a giant red flag of the system, which is that we actually had to register every property change prior to actually making it. And so this definitely led to some bugs. And it was very obnoxious to have to kind of keep track of all these things. But one thing that did come out of that is that it did kind of force us to be good in many ways. What it did was it forced us to have to be sane about kind of keeping track of every single property change that could happen in the entire editor. And so what we did then was we used the command design pattern. And I'm sure most of you, at least tools programmers out there, have used the command design pattern before. And just in case you haven't, what it is it allows you to take a request, encapsulate that into a structure. And you take that structure, you pass it to a dispatcher. That dispatcher then can decide who to pass that command off to. And those objects then can decide if they want to handle the command or ignore it. So this is what send command looks like. So the send command, so in the timeline control, we have an onMove handler. And by onMove, what I mean is that when you're actually clicking and dragging on the timeline to move the time at which something happens, this is the code that it looks like. And it actually is pretty much this exact same code. So what we do is, the first thing we do is we construct a move command, and we pass in the delta for that. And then on the cutscene state, we call send command, passing in the command, and a target enum there. And the target enum is nice because in this case, we're sending it to all selected elements. And so the cutscene state in this case is the one who actually manages all of the selection state. And the timeline control doesn't have to worry about it. So the timeline control says, OK, someone is clicking and dragging on me. I need to handle that. It just takes that command, passes it off to the cutscene state, and the cutscene state can say, OK, well, who is the selection? It's the one that actually has to worry about that. And we have all sorts of different targets. We've got all nodes, all visible objects, all objects, things like that, to handle all the different kinds of cases for who we want to send commands to. OK, so send command function looks something like this. First thing we do is we get an undo group. And by getting an undo group, it might create a new one or use an existing one, depending on the rule set and the timing and stuff like that. And it takes that undo group, and it sends that and the command to all of the targets based off the target enum that we are trying to send the commands to. And so for each of those targets, we just call handle command, passing in the command in the undo group. So handle command looks something like this. We take the command in the undo group, and first thing we do is we switch on the command type. And so what happens here is, let's say we're passing that command move to an animation element. The animation element will look at the command and say, oh, command move, I don't actually care about that, so pass it up to my base class. And in that case, it'll be the element. The element will say, OK, well, I do handle command move, so let's handle it. So the first thing it does then is it registers the undo item, just like we talked about earlier. And then it actually updates the start time. And this is just going to be something like mstart plus equal delta. And then it adds this object, this element, to the affected items list. And this is important because every command keeps track of every object that it affected. And we're going to use this in a moment. So once it adds it to the affected items list on the command, it returns an element change notification. So all commands, once they're done handling, they return back a notification code. So turn back the notification code. And what happens is we take that notification code, and for every single object that gets handled, we just OR together all of the notification codes, and we take that notification bit mask and pass it into commit commands. So what do we do with that? So I'm going to throw one more design pattern at you, and that is the subject observer pattern. And so for those of you who haven't used that before, it's a very simple pattern. All it says is you've got a list of observers, and you can take an observer and attach it to a subject. The subject then, every time that changes, anytime something happens on the subject, you can send a notification to all of the observers. And so in this case, the subject is going to be the cutscene state, and the observers are going to be all of the GUI controls in the editor. So what that looks like then is we take all of those notification codes from all of the objects that handle the command, and we just OR them together into the commit commands function, and that just goes through the observer list. And so let's say the first observer is the node tree. It passes the notification bit mask to it and say, do you handle element changed and element added? It says, no, I don't care about those, so just ignore it. Then it gets to the scene list and says, I don't care about those, so just ignore it. But then we get to the timeline control. Timeline control says, oh, the element changed notification, I do care about that, so let me handle it. And so in the case of the timeline, what that does is, all it does is it sets its dirty flag to true, so that next time Windows says it's time to do a new draw call, it knows, oh, I need to update my image prior to drawing to the surface. And so in this way, you can take hundreds of elements on the timeline, drag them across the screen. That all gets boiled down to one notification and one redraw on the timeline control, so you don't have all of that kind of, you don't have a lot of cost to redrawing the timeline. All right, so that kind of handles the main editing heartbeat there of the cutscene system. And so now let's talk about scrubbing. OK, so for those of you not familiar, scrubbing is when you can click and drag on the timeline and actually see the update immediately. And most animation and video software, they all have this. And it's really important to be able to see your changes kind of nice and slow or fast or whatever it is you're trying to do, or to be able to jump around on the timeline. And this is something we couldn't do in the past. So if you remember from our core principles, scrubbing must be exactly the same as playing. When you're at a given time, it doesn't matter if you jumped to that time or if you played and paused at that time. And I want them to be literally identical. You should be able to take a screenshot at the exact same time, whether you scrubbed or played there, and diff the images and see no difference. It also has to be very fast, right? Scrubbing means that you're actually clicking and dragging on the timeline. If every time you update it takes 2.5 seconds, well, that's not very useful, right? It needs to be practically real time. And some of these cutscenes are very large. We've got 1,000 nodes with very high-res assets. So this can be a bit of a challenge. So what we're basically asking for with scrubbing is random time access into the cutscene. The problem with that is that engines don't go backwards, right? So if you're at the 10-second mark and you want to change your cutscene to the 8-second mark, I can't just say scene update negative 2,000 milliseconds and expect everything to work. It doesn't work. That'll actually send it like way billion into the future. So if you can't go backwards, isn't that kind of the same as destroying your scene and then advancing really fast forward, right? So if you want to go from 10 seconds to 8 seconds, you can destroy everything, go back to the 0 time mark, and simulate back forward 8 seconds. And so, I mean, that's kind of the same thing, right? At least it should give you the same results, right? Well, it sounds kind of crazy expensive, right? Can you really afford to take your entire cutscene, reload it all, build it back up, and simulate forward? What if you want to jump to the 5-minute mark, right? How fast can you simulate to the 5-minute mark? Well, it turns out it actually doesn't have to be that expensive. The first thing to realize is that the most expensive part of cutscenes is going to be loading the assets from the disk. And any sane engine is going to cache those resources. And instantiating a new model from the resource cache, well, that's very fast. So we don't have to worry about that. We also don't have to recreate every single node in the cutscene. There's all sorts of nodes in the cutscene that, as you're scrubbing around, they don't actually change, right? Things like a bookmark node, or a folder node, or even a sound node. Sounds don't play back when you're scrubbing, so there's no reason to do any work there. And finally, you don't have to simulate the full history. It doesn't matter if there were 8 animations between the 0 time and the time that you scrubbed to. All that matters is the animation that you're actually on. So ignore all of the stuff from the past. We just care about kind of the key frames around the current time that you're jumping to. So this is what set time looks like in the cutscene system. The first thing we do is we send a set time command to all nodes. And set time is a command, just like any edit command. We have actually all sorts of non-edit commands, like even the main advanced time heartbeat of a cutscene, that's a command. And so what the set time command does when you're actually handling it in a node is that it just updates its internal node state. So if it's a kind of node that cares about set time, it's just going to update its internal node state. It's not going to update the world view yet, but just its internal state. And so as it does that, though, if it actually made a modification, it's going to add itself to that affected items list I mentioned before. So what ends up happening is at the end of all nodes handling the set time command, you then have a list of every single node that was modified as a result of that set time command. And so we take that list of items that are all the directly modified items, and we add them to the reset list. The reset list, what that does is it goes through all of those direct changes and determines the dependencies. And so if a given node was modified because of set time, it takes all of its entire children chain and the ancestry chain all the way from that node up to the root node and adds them to the dependency list. Because if a node was changed, it could possibly affect any of its children or its entire ancestry chain. And so, and also, on top of that, any node that is directly dependent on it, for example, like an attachment node, if you have like a muzzle flash attached to a model node, they have a dependency there as well. And so once we have the dependency list, we then know every single node that was either directly or indirectly modified as a result of the set time command. And so for them, we just call reset on those, another command that we pass to them. And reset, what that does is it destroys its representation in the world view and then recreates it with the new internal state that it has. So in this way, you're able to have a fairly minimal list of all of the objects that need to be updated in the scene, and we're able to quickly destroy them and recreate them. And so even scenes that we have 1,000 nodes for, we can, in very expensive assets, you can scrub on the timeline in real time, at least in release. All right, so that reset command I just talked about, this is actually the same reset we use for all changes. It's not just used for set time. So if you want to change a model from the Marine to the Marauder, for instance, the moment that you hit enter in the property sheet, what we do is we send out a set property command, because the property just changed. And that node, when it handles the set property command, it got added to the affected items list, as I mentioned. And it will end up going through that same chain that the set time command did. And so what will happen is that one node will be in the affected items list. We get all of its dependencies, its children, its parent, and maybe there was a muzzle flash attached to that weapon. That smaller list of nodes will all get a reset command, and they will all immediately update inside of the viewport. And so in this way, when you make a change, we have kind of a nice tight list of all the nodes that actually have to update. The other ones, they're fine to stay. And every time you make a change, the moment you make the change, your scene is back in the exact same state it should be in for that time. All right, so that handles scrubbing. And that is the end of the tech part. So any artists that are left didn't leave. You can wake back up now. OK, so let's talk about some lessons learned. So one of the coolest parts about working in the cutscene system was kind of witnessing this idea of the emergent workflow. And we hear all the time at places like GDC the idea of emergent behavior, right? You got emergent behavior with AI systems, emergent behavior with players, stuff like that. And so it was really cool to see what happened, as this emergent workflow from people using tools in ways that we never intended. And kind of, I think the best way to capture that is if you let your developers go crazy, cool stuff will happen. And so we had all sorts of different ways in the cutscene system where they ended up using the cutscene editor in ways that we never intended. And so kind of the first one, and probably the most natural of these, was this idea of these ambient sequences. So in StarCraft II, both in Wings of Liberty and Heart of the Swarm, you have all these background characters that are just kind of giving life to the scene, right? You've got some crew members walking around in the background, TV screens blipping, and in Heart of the Swarm, you got mutalisks flying around, things like that. And so these are kind of non-interactive, just ambient sequences happening in the background. And so what happened was, in the past, they used to be created in Max as a specific animation on a given model. But what happened was the artist kind of in charge of it, he got used to the workflow of creating the cutscenes. And so what he ended up doing was he came to me, he's like, hey, can we just create cutscenes without cameras and just play them back? And so that worked. What we did was we created all these cutscenes. You had things like mutalisks flying around and larvae coming on the screen and zerglings walking around, things like that, where they created the actual scripted sequence in the cutscene editor, and then we just played it back in the game world, right? It didn't control the camera, it didn't take control away from the player. These were just things that kind of played in the background. And we ended up layering multiples of these together. So you can have any number of cutscenes playing simultaneously. So what would happen is, like in the Leviathan set, you'd have all of these mutalisks kind of flying around in the background. There could be 5, 6, 7 different variations of a cutscene playing in the background, layering it together, giving it this kind of cool, organic, living feel of the Zerg. The next kind of weird thing they did had to do with set lighting. So in Wings of Liberty, all of the lighting for the story mode sets was created in 3ds Max, right? So the lights were actually added to the set model. But the problem was there that they had really slow iteration time because they'd be creating the model and they want to add the lights to it. But they had to kind of do it blind in Max and then push the preview button and see what it looked like in the engine. And so every time they wanted to make a change, they had to go through this preview process. And what happened was the artist that was in charge of doing the lighting for the cutscenes, he got to the story mode sets, and he wanted to use that kind of real-time system again in the cutscene system to visually create the lights. And so what he did was he came to me and asked, hey, would it be possible to just make a cutscene that has nothing but lights in it and then play that back in the set? And it sounded kind of weird. I was like, wait, you're really going to make a cutscene that's just nothing but lights, and we're going to play that in the set and just have the lights kind of pointing at the characters and just keep that cutscene paused forever? It sounded weird, but there was no technical reason why he couldn't do it. So he said, yeah, go for it, see what happens. And so that's what we did. That's how we shipped Heart of the Swarm. So we created these cutscenes with all these vertical slices of nothing but lights in them. And for a given character, character position, or whatever kind of light we wanted at a time, we would create the cutscene in the game, jump to the time for the correct vertical slice of the lights, and then just pause the cutscene and leave it there. And so in this example here, you can see Kerrigan sitting there with all of her lights there. And then same exact cutscene, just move the time, and now this is the state for Isha here. So you had all these cutscenes that are just sitting there in a paused state, controlling the lights. And it's definitely a weird thing, but this is the workflow they wanted, and created a better game because of it. And so the weirdest of these is definitely these hybrid conversations that we ended up creating. So what happened was in Heart of the Swarm, in Heart of the Swarm, we still had a lot of these standard conversations, right? And these are things that weren't really worth kind of promoting up to cinematic cutscenes and hand creating. So we still used the procedural conversation system to play these back. Things like just 2 or 3 dialogue lines in a row. The problem with that, though, is that the procedural system still needs us to define the cameras, right? We still need to be able to say what cameras to use for a given dialogue line. And the way that worked was that you had to go back to the terrain editor, like I mentioned, and kind of blindly create these cameras. And the artist didn't want to go back to that workflow. He was used to just kind of pointing at them in the cutscene editor. And so we ended up going with a user-driven workflow here, where he came up to me and he said, look, I don't know exactly how I want to do this, but I want to do something different. I want to be able to use the cutscene editor and the kind of the visual creation of cameras while still taking advantage of the procedural conversation system. So we kind of talked about this and came up with a bit of a compromise. It's a little bit weird. It's a little bit dirty, but I'll show it to you here. But before we do that, I'm actually going to jump onto a soapbox. And and say something here that is a little scary to be in front of a room full of engineers and say, but I think it's worth it. I think it's really important. So I'm just going to put it up here full screen. Do not sacrifice tools usability for engineering purity, right? And so what I mean by that is, I'm not saying that your code should be a mess or you don't worry about your architecture or anything like that. What I'm saying is that it's easy for tools programmers, or programmers in general, for us to create kind of a new system, and we're like, oh, okay, we got this nice clean API, we're really happy with how this works, everything is perfect. So we pass it off to the artist and say, okay, do your thing now. And they come back and say, oh, cool, how do I do this? And we're like, oh, the system wasn't designed that way, right? And so, what you're doing when you're saying no because the system wasn't designed that way is you're sacrificing tools usability for engineering purity. And I think that's a mistake. I think that, everyone wants to make better games. That's why we're all here, right? Everyone wants to work together towards this common goal of making better games. And so, I think that we should, when we say that the system wasn't designed that way, we should come up with, how can we make the system that way? Or what kind of changes can we make? Or, should we just come up with some kind of compromise? And so that's what we did in this case, is we came up with a compromise. And fortunately, for the engineers out there, we did hide all of the ugliness under script code, at least. And so what we did was, for these procedural conversations, we needed to define the cameras, right? And so similar to the lights, we created cutscenes with these vertical slices. And each vertical slice would say what the camera was supposed to be at a given time. So if I zoom in here on the timeline, you can see here I've got a Dehaka Kerrigan close-up bookmark there, right? That green bookmark there. And so what that's saying is that this slice of time here between the start and the end is what the camera should be for any conversation line that's between Dehaka and Kerrigan and marked as a close-up. And so what we would do is the procedural conversation system would still do exactly what it does and play the animations on the characters and play back the dialogue lines and do its normal thing. But at the same time, it would also create this cutscene, jump the playback of the cutscene to the bookmark for the given speaker, listener, camera combination, and then it would play from the start time to the end time, scaling back playback speed to match the duration of the dialogue line. And so what that gave us was the ability to use the visual system to create the cameras while still taking advantage of all of the conversation procedural system. And it also gave us a couple new things by accident. We didn't even realize at the time that we were talking about this. First off, because we are playing back this cutscene, and the cutscene's really only controlling camera primarily, because we're playing back this cutscene, we actually now have animation for cameras. So in a given line, we can actually define a different camera position for the start and the end, and it will just kind of drift over as it plays back. And so this is a new feature we didn't have before. We couldn't actually have a small tween on a camera during a conversation line. And so just kind of by adding this, allowing them to do this crazy stuff, they got a cool new feature out of it. But kind of most importantly, they were able to do something they could never do before, and that was have per camera shot lighting. And so I'm going to kind of illustrate. So what I mean by that is, because we are just playing back a cutscene here, we're not doing anything that's in the cutscene will come back and play back. And so after they did all these cameras, they're like, wait a minute, what if I just put a light on her, right? And we play that back. Well, then she would have the light on her because we're just playing back the cutscene. And so I'll kind of illustrate what I mean here to show you a shot here. So this is a shot from Wings of Liberty. And in Wings of Liberty, all of the lights were done on a per model basis, on a per set basis. And so if you look in the background, you can see the lighting looks great there. You can see nice hot red lines on the forged kind of Terran thing on the right side, and on the left-hand side in the background, you can see this cool nice spec lines on the Xel'Naga artifact. It looks nice and nice and cool. But the characters in front are kind of flat because no lights were ever designed for the current camera view and their locations. So in Heart of the Swarm, though, this is what it looks like. So with no major change to the graphic system or the lighting system, we now have a much higher fidelity because the lights were able to be customized for every single camera shot in character. So if you look at Abathur there, on the right-hand side, kind of under his claw, you can see this nice blue rim light there. And kind of in the background of his head, he's got a nice glow for that, like that zergy, brainy feel. And even right on his chest in the front, he's got nice spec lines there to kind of make like a slimy Zerg feel. And just by listening to the artists and letting them kind of dictate how they wanted to work, we were able to kind of get this accidental feature out of it and create better looking sets that we didn't even expect or characters that we didn't even expect we were going to do. So that kind of brings us to the title line of this talk here, and that's cutscenes everywhere. So this is just a random shot I took in the story mode set. And if I zoom in here on the debug overlay for cutscenes, you can see we actually have 8 cutscenes playing simultaneously. And this is actually an interactive portion of story mode. You just clicked on a character and a conversation is being played. We've got 8 different cutscenes playing back. We've got 3 cutscenes that are controlling the various lights, the spotlights on all the characters on the set. We've got another 2 cutscenes that are controlling larvae that are just walking around on the Leviathan at this moment, and another 2 cutscenes for the mutalisks that are flying around in the background. And then finally, we have one more cutscene that is controlling the current camera for this particular dialogue line and the environment light for that same line. And so in this way, we're able to take all of these cutscenes, layer them together, and create the entire story mode experience by just taking these cutscenes and just kind of making them all happen at once. And all of this stuff here, this was nothing that we intended. We intended that cutscenes were going to be kind of like videos. And by letting the artists go crazy, they ended up constructing the entire story mode set using these cutscenes. So we did have a couple challenges, of course, while building this system. And the first is that we didn't give ourselves enough design time. And so even though we did have a fairly formal design process, as I talked about in the beginning, we actually could have spent even more time. And what happened was we had a really striking difference between things that we spent a lot of time on, like the timeline, versus something that we didn't spend a lot of time on, like undo. And so we really should have spent more time on those other systems, and we would have had a better result, I think. We also kind of forgot about sound. I mean, obviously, we knew we were going to have sound in cutscenes, right? We knew that we were going to have dialogue lines and sound effects and that kind of stuff. So we had features for that. But if you notice that as I was talking throughout this entire talk, I talked a lot about the artists and the animators. We didn't really work with the sound guys the same way that we worked with the animators. And that was a big mistake. The sound guys, what happened was we created all the cutscenes and we were kind of done with them, right? And so we just passed them over the fence and said, OK, sound guys, do your thing to these cutscenes. But we had no idea what their workflow was, right? We didn't work with them at all. And that was a big mistake, because what happened was at the end we had to scramble because they started asking for all these features and all these workflow improvements that we didn't even consider. And this was at a very late stage in development. And so we really should have brought them in from the very beginning and dealt with them the exact same way we dealt with the artists. And so the key takeaway here is to deal with all of the content creators, right? Not just the primary content creators or the people that you sit next to. And finally, we had a lot of challenge with creating content at the same time we were building the system. So everything I just talked about there, all the stuff that we built, was during development of Heart of the Swarm. And so what happened was they started creating the cutscenes at a very early stage. And I'll definitely say, it was very important and very good that the artists and animators were involved from the beginning. But the problem was that because they were involved from the very beginning, and the only way to really give good feedback was to use the cutscene editor, in a real way, was they started creating cutscenes before we were done, right? So the system was still unstable. The features weren't all there. And what that did was it created all sorts of problems with things like lost work, right? The system was still unstable. They'd be working all day and then discover, oh, wow, the save system is saving out 0-byte files, things like that. So, I'm still kind of confused on exactly how to take something away from this, because without question, I want to involve everyone again the next time we do something like this. But at the same time, we need to have some kind of processes or some kind of consideration to mitigate lost work, because any lost work is unacceptable. All right, so that is the end of the lessons learned. And for anyone paying attention, the creep spread is complete. All right, so I've got one more slide here before I'm done. I'll just kind of let it go there. So while making this presentation, I decided to take some stats to see how many objects we had in our cutscenes or whatever. And so we had about 98 cutscene files, and maybe 20 of them or so were those weird lighting and camera cutscenes. And across all those cutscenes, the number on the bottom right there is kind of my favorite. They created 94,000 elements, things like keyframes and camera cuts and animations, things like that. I just couldn't believe that they created 94,000 of these. And we're talking about maybe 4 to 5 artists over the course of 9 months to a year or something like that. So that's just kind of insane to me. So anyway, that's the end. So it looks like we have some time for questions, if you go up to the microphone. Hey.
Hi. I noticed that you didn't mention any post-processing effects in your system. Does your system support it? Well,
so I mean, the lighting system and just the lights in general, they have a lot of post-processing there. But also, the IGC cutscenes, they were created in the cutscene editor, but then what we did was we rendered those out and then brought them over to whichever video software they use, and they kind of polished them up there. I mean, for 2 reasons. One was we wanted to be able to have the same graphical fidelity across all graphics settings. In Wings of Liberty, we didn't have that, but in Heart of the Swarm, all players were able to see the same graphics fidelity. It also allowed the artists to ignore budgets, which better or worse. But also, they were able to do things like some of the post-processing they did in cutscenes like the one that this concept artist ran.
Are there any plans to do any real-time rendering for cutscenes? I don't know why.
Well, all of the cutscenes in Heart of the Swarm are real-time, except for the main pre-rendered ones. And the IGCs, they can be played in real-time, but we chose to pre-render them for different graphics options reasons.
OK.
Yeah, so everything you saw here, the things like the conversations and stuff, that's all real-time.
All right.
Yep.
Thanks.
I'll go over here, I guess.
OK, thank you.
Yep.
Thank you for excellent presentation. I'd like to ask my question about the conflict problem. And if I make a cutscene on myself, it's no problem. But actually, if I make a cutscene and involved a lot of stuff, for example, the camera artist and lightning artist, a lot of the stuff involved on make a cutscene.
Right.
And it occurred a lot of conflict cutscene file. In my case, when I make a cutscene system, the server is separate file, and each the person.
So,
and
go ahead.
How can you get this problem?
So I think what you're asking about is how do you deal with collaboration and different people working on the cutscene at the same time, right?
Exactly.
So we had a couple things. I mean, one, it's an XML file, so they are mergeable, right? Also, we had a reference system so that you can actually reference objects from a different cutscene into a cutscene. So some people were able to work on kind of the base cutscene, but then we would layer another part on it on top, and they could work in different files that way. Also, we were a small team, right? So we just kind of, people worked on different things at the same time. We had 2 primary people who were the cutscene artists. And then at various points, we brought other people in as well. So we didn't have that much trouble with things like conflicts.
OK, thank you very much.
Thanks.
Hi, Matt. My name is Ines, and I actually work in the localization team in Europe.
Oh.
And so since you talked about, how you supported localization with your tool also, I wanted to have your point of view, because I always focus on our issues, What was the biggest challenge for you to support our team's work?
For localization?
Yes.
Yeah, so localization was challenging. So the cutscene system, in the very beginning, we knew we'd have that challenge, right? We knew that we'd have dialogue lines of various lengths. We also knew that Kerrigan would have different lines depending on if she was in her primal form or not. So we knew we had to deal with this concept that dialogue could be at variable length, right? And so we added this linking system, right? And I had linking up here as one of our greatest challenges at one point, but because I was short on time, I ended up cutting it. But linking was a big challenge. I don't know if Rick is here. He still curses my name because of it. The idea is that in the cutscene editor, in theory it sounds great, right? In the cutscene editor, you can link elements to each other that create a dependency among each other, right? And so when you move something, or if something gets resized as a result of the asset either changing during development or because of a different localization, we would maintain those relationships of how much they'll link to each other. So if you stretch out a dialogue line, everything that's dependent on it will get pushed out or pulled in, depending on which way you're going. Which in theory worked, and we did ship with that too. We did have that, but the challenge was with authoring it, right? What happened was that in order to support that, it was basically an all or nothing system, right? Either everything was linked perfectly, or you had one bug, or you were kind of in partial progress, and it would get very strange results, right? Because unless everything is perfectly linked, it was really hard to move everything appropriately. So it was definitely a challenge, and basically we just put a very, very smart person in front of it and said, work it out.
Thank you, and good job.
Thanks.
Question, was there any sort of a repository built for the content creators?
I'm sorry, say that again?
Like some sort of a repository?
Well, yeah, everything that it worked on would get checked into Subversion, if that's what you're asking.
No. The actual content, not your code, like whatever they were doing. Like if they wanted.
No, that's what I mean. Like, yeah, all of the XML files, the cutscene files themselves, they would go into the repository as well. We have our code repository and our data repository. It goes in the data side, but yeah, of course, everything was under version control. Okay.
Yeah. Hi. Did you ever have level designers want to use this to do like environmental storytelling in missions?
So we did a little bit of that. And we talked about all sorts of fun things we can do with that. And we did add support at one point to do things like seamlessly create a unit from a cutscene actor. And so what we always talked about, and it is possible using the current system. We did use it in one of the missions. What you can do is you can play back a cutscene, right? And then using some kind of fancy triggers that we added for support of this, what you can do is we would create a unit where the cutscene actor was, clone all the animation state and the exact particle state and stuff like that, and then create a unit and then delete the other guy, and it would, I'm surprised it worked, it would seamlessly transfer from a cutscene actor to an actual in-game unit. So we did that in a couple of the missions in Heart of the Swarm. We kind of just toyed with it, but in Legacy of the Void, I expect we'll do a little bit more with it.
Thank you.
Thanks.
So it's 6.
Oh, okay. Can I take one more? Okay. Sorry.
It's 6 o'clock in the evening.
Yeah.
Oh, it's 5 o'clock for Friday, so I have a question. Do you have a program for former game developers who spent a year of their lives trying to get into Master?
I'm sorry.
Trying to get into Master League?
I
If you have a program for game developers who try to get into Master League and spend a year of their lives, it's just for fun.
I'm sorry. I'm sorry.
So basically, I spent a year of my life playing your game, and I'm asking if you have a program for people like me.
Oh, no, yes, no, okay, I'm sorry. So you're talking about modders, right? Okay, sorry. Yes, I mean,
we're all tired.
Yes, no, I know, please. So everything here is available to the modders, and we often made lots of decisions, in order to support the modders. And in fact, at the very end, we kind of had to do a bit of a scramble, similar to the sound thing, to make sure that everything that we released out to the public was modder friendly. And I don't think that we did a perfect job at it, and we're still improving it. But I mean, everything here is available to the modders.
You still made a great game.
Thanks. Cool. Well, thanks for coming.